Hello everybody. So here we have exercise 3.3. And we're said that there is two objects with these two graphs for entropy against our energy. Now I like to solve this problem and to actually understand it better, to create a graph where these two are on the same graph. And I'm gonna use S as the entropy, because it can be either A or B, and then I'm gonna use U of A for the x-axis. Okay, so here we have the uh, first one that will be like this. The second one instead is going to be the opposite because of course we are starting to decrease it. So we have, let me use the curve. Okay, so the energy that we have at the initial point is not going to be the final energy because the final energy has to have some specific values. As we've seen in chapter 3.1, the first part, our derivative in terms of u for a has to be equals to our derivative of s of b, sorry, in terms of ub, or in terms of s of a, actually, because this is s of a, and these are s of b. B in terms of u a minus, no, sorry, plus s of b in terms of u of a. So now we have our graph again, exactly like we had in the first. I mean, draw this as better. Okay, like we had in the first part of this chapter. And we have to find a point where the two slopes of S of A, S of B in terms of U of A are the same. Sorry, not the same, are the opposite, and they are going to be, they're going to be our, uh, and they're going to be together, they're going to be equal to zero. So even though our graphs are not perfect, we can say, we can imagine, for example, these two slopes right here are going to be same absolute value, opposite magnitude. So the final energy will be this point right here, U final of A. And of course, let me write it like I did before, UF final, and then U B final will then equals to U tot minus UA final. Um, the important thing is that we have to look at the slope and find where the two slopes added together equals to zero when we are deriving in the same terms, both in terms of UA. Now, if we look back at this, we'd actually say that this slope right here, I'm going to say, is the same as this slope right here. So the final UA, the initial UA final, is going to be this, and the UB final is going to be over here. Okay, because as you can see, U of A increases, then UB has to decrease, of course, because the total energy is constant, it's fixed. And this is the solution to our problem. The two slopes have to be the same. Now we graphed it into this third graph, just to make it easier, I believe, or at least for me to see. But if we go back at our initial two graphs, we can see the slopes have to be equal in magnitude. And since they are derived in different terms, we're going to use this formula right here. The two slopes have to be the same, both in magnitude and direction, because they're derived in two different terms that are opposite to each other.